Good morning, evening, afternoon, middle of the night, whatever. Let's start by logging into Clever. All right, here is your warm up. What is your favorite superhero and why are they your favorite superhero? Great. So, welcome to lesson 7. Today, we're kind of finishing up our conversations about water properties and using this kind of short, different week to hopefully get ourselves caught up and in a good place. So first of all, as always, make sure you are checking assignments from previous weeks for comments, for returned grades, for questions, etc. The same deal with ed puzzles. I do most of my grades on Monday, most of my grading on Monday. And I did do that this week. So there are updated grades on both Google Classroom and on Infinite Campus. Remember our expectations. It's super important, especially as we get really close to the transition to our safe, responsible, respectful, prepared, and here classroom in our COVID pandemic actual classroom. There are parent-teacher conferences, and once again, they are not traditional. I'm going to be reaching out to some folks to try and talk to your parent or guardian to help get you set up and in a good place to be successful this semester. If any of your parents want to speak to me personally, please do not hesitate to pass on my information so that we can coordinate something with them. So this week, again, we're talking about water and water's properties and its structure. And we're moving towards then next week, we're going to be thinking about how do humans and the environment affect our water and what does that mean? So this week is kind of late because we don't have school on Friday. So our really only true lesson is Tuesday and Wednesday. This lesson 7, what you're doing right now. The assignment that's going to be posted on Thursday for everyone is not going to have a true full lesson that goes with it. There'll be a short introduction to make sure you know how to do the assignment, and then that assignment is kind of a transition into what we're doing in our next unit. Next week. Another big thing to think about is I was not pleased with how quizzes were going in the previous 2 quizzes. So this week and this week only, they are open for retakes. So if you did them the first time and didn't do great on them, they are open so that you can go and edit your answers to improve your scores. Like I said, this week's kind of weird. I'm not, because I don't have classes, we won't have classes on Friday. I don't want to make my first, second, third period do something additional. So it's going to be slightly adjusted, and there's only 3 assignments this week. Thank you guys for showing up and for being here. Let's get started. So take a look here. You see water droplets that are forming water droplets and then sticking to a spider web. Which property of water are you seeing here, and how do you know? Right. So there's a couple ways that you could have gone with this. You could say that because you see these water droplets, that's showing cohesion, the water coming together. You could say that you could see adhesion because these water droplets are sticking to the web. You could say surface tension because you see the outside, that surface of those water droplets, right? What about this one here where we see a solid substance being dropped in and mixed together and dissolved into our liquid water? What property do we think we see here, and how do you know? So once again, there's a couple of options. The most obvious one is that water is a universal solvent. So it's dissolving that substance, probably salt or sugar, into it. And that occurs because water is polar. You could also, if you wanted to talk about, you can see the surface of the water here, so surface tension. You could talk about water being adhesive and sticking to that mixer and to the glass. But the main one that you might want to identify is the fact that water is a universal solvent. All right, and then last one here, a freshly waxed car with water droplets forming on the outside. What property do we think we see, and how do we know we're seeing that? So again, multiple directions you could go here. You could say that since there's those water droplets kind of condensing together, that shows cohesion. Although it appears that the water molecules are sticking to the outside of this car hood, after it's been waxed, the point of the waxing is that it doesn't allow water to stick, that water is actually going to roll right off. And the reason for that is because wax, just like oils or butter or fats, does not mix with water. That's like really one of the few things that does not mix with it. But you can also say that you see surface tension because, again, those water droplets have those nice curves on the outside. And I would accept adhesion because technically it is sticking to something. Okay, so in our live class, what we did was some small group talk about a specific phenomena and thinking about why that property of water is being seen there. So, because you can't do this with a small group, you're going to do this on your own. So, each of those three examples that we did in the warm up, you could have told me that you saw cohesion, adhesion, or surface tension. Because pretty much anytime we see water doing anything, you can probably see either all three of these or at least one or two of them. And so, as a reminder, when we talk about surface tension, we're talking about the fact that water molecules have hydrogen bonds that connect them to each other. And on the surface of a body of water, be it a tiny little drop or a whole lake or pond or something like that, on the very, very top, there is almost like this web of water molecules that are connected that create this like almost solid surface. And that's what allows a water droplet to keep its shape, or when you smack the surface of a water, it feels like you're hitting something solid because of surface tension. Cohesion is the fact that water molecules like to stick together. That's literally what's going on with hydrogen bonding, is that water molecules are all interconnected to each other. And then adhesion is the fact that water molecules can stick to a lot of other things. And that's because if those other things have charges, the polar water molecule with either its negative or positive end will be attracted to and stick to it. All right. So all of those three properties are tied directly to the fact that water is polar. So it has this negative end on the oxygen and then this partial positive end on the hydrogen, or the fact that the water molecules will stick together through hydrogen bonding. Okay. So there are some really interesting properties and phenomena that we can see out in our natural real world. So the first is this Jesus lizard that is walking on water. That's why he's called that, but the green basilisk. A rain chain is another really interesting one, where water forms streams that is directed into a bowl because the water comes together on those chains. Our little water strider creature that is sitting on the top of the water, we can see its cool indentations there. And then this one is really, really interesting. It's a person wringing out a towel with water in it and gravity. And we see that water sticking together there without getting him all wet. So all of those can be directly tied to the fact water is polar and to the fact that water hydrogen bonds to other water molecules. So what I'm going to ask you to do is explain in your own words, how a property of water is visualized in a particular phenomena, and explain to me how the hydrogen bonding or polarity is causing that to happen. So as an example, let's take a look at this phenomena here. So this is the bottom of a leaf where we see water droplets forming and then water droplets coming together to form larger water droplets when they're sticking on there. So the first thing you're going to do is write a detailed explanation of what's happening, but you don't have to do it necessarily in scientific terms. So here what we see is that water is collecting into larger droplets when they get closer together on the surface of a leaf. So it's sticking to that leaf, but also the water droplets are forming their water droplets, right? So the next thing that you're going to do is identify which property of water you might be seeing. So you could say adhesion here, that the water is sticking to, we see adhesion because those water droplets are sticking to the bottom of a leaf. You could also say cohesion because we see those water molecules coming together to make an even bigger water molecule or water droplet, okay? So then the third piece of what you're going to do is you are going to think about why that's happening in terms of either polarity or hydrogen bonding or both. So for this case, if we're talking about adhesion, we're going to say that the surface of the leaf must have a charge that the polar water molecule is able to attract to, causing the water droplets to stick to the surface. If you wanted to talk about cohesion, we would talk about the fact that when those droplets got close enough together, hydrogen bonding overtook those separate, and so they were able to kind of morph into a larger water droplet, right? Another one you could talk about is we could say that we are seeing surface tension here because we see that beautiful round shape of each of these water droplets forming, and that's because of the hydrogen bonding that is taking place on the surface of the water molecules. So there's lots of directions you can go with this. The main point is I want you thinking and writing about it. So here's what you're going to do now, and I'll put you through the step. You're first going to take a look at the GIF that I'm going to show you. You're going to start by describing it in non-scientific terms and just explain to me what you see happening. Then you're going to identify which property you think is seen and how we're seeing it. And then you're going to explain how the water's polarity or hydrogen bonding is causing this property to occur. All right. So the property that you are going to be talking me through is right here. So this green basilisk or Jesus lizard running on top of water. So first, describe to me what you see happening. Awesome. So what we see happening is this green basilisk he's flinging water. So that's one thing you could talk about. But you also see him, his feet hitting the surface of water almost like he's running on a solid, right? When it's actually a liquid that you're going to fall through. All right. So the second thing that you're going to do is tell me what property of water you're seeing and how you're seeing it. So if you are talking about the water that's flinging off as he's running, you could talk about cohesion, right? Because those water molecules are sticking together in those streams that are falling off. You could talk about the fact that he's getting wet and there's water that's on him. That could be adhesion. Or you can be talking about the surface tension that we see here as he runs across the water, that there's almost this surface that's hard that he can then use to propel himself on. Last thing you have to do is then explain to me how that property is occurring in terms of either polarity or hydrogen bonding. All right. So if you're talking about surface tension, we're talking about how hydrogen bonding of water forms a layer on the surface of the water that allows the interesting and uniquely shaped feet of the green basilisk to run on top without breaking the surface so that he can actually run on top like it's solid. If you're talking about adhesion, you might talk about the fact that that water is polar, so it can stick to his scales that must have a charge. Or if you're talking about cohesion, with these water droplets or streams and flicks of water coming off, as they're staying together as visible water as opposed to individual molecules, because water is cohesive and they want to stick together. Okay. I hope that was helpful for you to kind of put together in your brain all of these pieces of properties and structure of water that we've been talking about for the last 2 lessons. All right. So your other assignment is this reflection question that is essentially having you do the same kind of thing. So writing about what you see and what's going on with the property of water. So we'll finish with this. How did you like the lesson and what did you like? Cool. And if you don't have any other questions, I will see you later. Have a great rest of your week. Bye.